we are trying to find the solution to the systems of linear differential equations using the Laplace transformation. So it is an application of Laplace transformation in solving systems of differential equations. What is a system of differential equation? This system will involve two or more equations containing the derivatives of two or more unknown variables, which may be in terms of some independent variable t. So you can have x, y, or x, y, z as functions of t. And let us see some examples here. The first system has got two variables x and y, which are in terms of t because we are trying to find the second derivative and equating that to another expression negative 5x plus 4y or 3x minus y. And the second example is also a system of differential equation. Here we have got three unknowns x, y, and z, and all those three variables x, y, and z are in terms of t. Now, in all these equations, we are trying to find the solution to a system of differential equations. The solution to the system of differential equation is nothing but a set of results like x of t equal to f of t, y of t equal to g of t, or z of t equal to h of t. When you're solving the Laplace transformation method for the system of linear equation, there are three steps to remember. The first one is you have to find the Laplace's transformation for each equation in that given system. So that will give you an equation in terms of x of s, y of s, and z of s. And the second step is try to solve those equations and get the values of x of s, y of s, and z of s. And finally, take the inverse Laplace transformation of these three results and try to get the solutions x of t, y of t, and z of t. Let us take an example here. We have two unknowns, x and y, where both x and y are functions of t. And there are some initial conditions given here. We will be making use of these initial conditions. But when we are trying to solve these equations, you should recollect the Laplace transformation for e raised to negative t, Laplace transformation for sine of 2t, Laplace transformation for the second derivative of x, Laplace transformation for the first derivative of x, and the Laplace transformation of x, the same way for the different Laplace transformations for the variable y. So in our first step, we are going to take the Laplace transformation on both sides. So when you take the transformations on both sides, you may end up getting these two equations, these two new equations what we have. So this is our first step. We are going to make use of these results what we got in first step, and in our second step we are going to take the transformation, Laplace transformation on both sides, which will lead us to find the value for x of s and y of s. So you got the solution of those equations from step 1. After taking the Laplace transformation, you got an equation, two equations in terms of x of s, y of s. You are algebraically solving those two equations to get the results like this. Take the inverse Laplace transformation of both those equations, apply the inverse Laplace transformation for the right hand side. That will give you the final result of x of t and y of t. So this result, what we see, is the solution for the given differential equations. That is, the system of differential equation will have the solutions of as x of t and y of t as given in this page. We learned a method to solve the system of linear differential equations. I hope you enjoyed this video. Thank you. Thank you for watching.